Good morning, friends. Today we will be solving some problems of maybe nuclear physics, binding energy, etc., radioactivity. Some simple questions like multiple choice, which are asked in the JEE or NEET examinations. Multiple choice, maybe 4 choice, you have to select one. So, friends. And then I will be doing some problems as an example. You can do some more, but for some example, I will be talking about some important problems. Say today, first problem is the binding energy per nucleon. The binding energy per nucleon of H2 and 2He4 of 1H2 and 2He4, that is the deuterium, and this is a helium. So the binding energy of deuterium and helium are 1.1 MeV and 7.0 MeV. Respectively. So these are the binding energies. Energy released in the process. Energy released in the process which process? The process I gave is 1H2, that is the deuterium, disintegrating or deuterium plus deuterium, yani the interaction of deuterium plus deuterium, where we get 2 helium-4 is. So this is the multiple choice, that binding energy per nucleon, binding energy for one nucleon in He2, that is the deuterium, is 1.1 MeV and helium-4 7.0 MeV. So this process, the fusion of deuterium and deuterium gives helium. So energy released in this process, how much energy released? Their choice A, 20.8 MeV, say B choice is say 16.6 MeV, choice C is say 25.2 MeV, choice D is 23.6 MeV. So these are 4 options. Well, you have to get the correct one. You have to tick mark. Either A is correct or B or C or D. Now how to solve? Use this and this. They fuse together to give this. You know that when proton-proton or proton-neutron fuses together, proton-neutron separate masses are much larger than the mass of the complex system, that is the deuterium, because there is a mass loss, and that mass loss is binding energy. If you want to separate the constituents of deuterium, that is the proton-neutron, you have to supply that energy, which is lost when they are produced. So when this is produced, some mass converted into energy. Energy evolved and we get helium. So what is that mass loss? Means this and this combined. So you have binding energy per nucleon for this. How much? When this combines, one nucleon comes here, this much energy loss. When another nucleon comes here and this becomes helium-4, there is a binding energy 1.1 plus 1.1, total loss. And binding energy for, so find out how much energy loss. When 4 nucleons combine together, how much energy? Per nucleon 7. So this is 28. So how to solve? Which result you will get? This or this or this. So what to do? You can say this energy released in this, maybe say, in the process, you can say the Q, energy of this. So what will be the energy of this? Means mass differences of this. When mass loss, that difference, delta M. So what is delta M? How much? When this gives how much and this gives how much. So all that mass loss when this interaction takes place. So how much? This is, remember, for this, it is 7 MeV per nucleon. So 28. So here, when 4, that is the mass difference of two sides. Here, when 4 nucleon combine to give helium-4, mass loss, energy evolved, this is on this side, 28, the energy. Seven MeV per nucleon. So 7 into 4, because 4 nucleon, there are 28 MeV. 28 MeV here, energy. And to fuse this, how much energy is needed? For H2 and H2 combination, energy or mass loss, energy evolved, mass loss. Here this is how much? 1.1 plus 1.1, that is 2.2 MeV. So on this side 2.2 MeV energy, on this side 28. Here you can say, so how much? The energy difference, 28. So energy release in the process. How much we get? 2.2. Here 2.2. Here also 2.2. So 4.4 total. This means this is 4.4 MeV. Energy evolved from this side. This is left side, this is right. It means energy, one energy positive, one energy need. It means when you are combining, you need, this is mass loss is there. On this, but this whole must be equal to this. Here it is 28. So 28 total energy evolved. Is 28 MeV on this side, right side, 28.0. This side, 4.4. So this means (23.6 MeV). So 23.6 MeV energy here. This answer is correct. So D part is correct for this. Means energy released, energy evolved. Because this is on this side, this is on this side. So this much energy for 4 nucleon combined, this much energy evolved. Here per nucleon is 1.1. So 2.2 here and 2.4 here. So how much difference energy? Energy evolved at 28. Energy, you can say this is energy used for the making alpha particle. Means when these combine together. So the difference of energy on this side, when you transfer this, Q is equal to, this becomes minus on this side, means energy evolved is 23.6. So this part is correct, D part. Okay. Now we see next question. Next question I write question number 2. 92 uranium 238 absorbs a neutron. Absorbs a neutron. The product emits an electron. The product emits an electron. The result is what do you get when this emits electron? So this is beta decay. Answers are A is 94 plutonium 239, or B is 90 plutonium 90 Pu. There is some mistake in this because both charge cannot be. Pu cannot have 90 to 90 charge. So there is some mistake in just they have written anything. C is 93. So which is correct? 93 Pu, 93, 237, and D is 94 Pu, 237. So this is decaying. How decaying? The product emits an electron. That is beta decay, electron emission. And you know beta decay, neutron changes to proton, means beta negative decay. Mass remains same. So whatever, because neutron changes to proton, mass nearly same. So what happens? 92 uranium 238 is decaying. Sorry, no, it is correct. Now which is correct? 92 uranium 238, not beta decay, emits an electron. Okay, what will happen? How to get this answer? Which is correct? It is emitting, it is not decaying. Sorry, not decaying. Its product emits an electron. Uranium 238, 92 emits the electron. So electron comes out. Electron is of zero mass, or mass be right here, zero mass and minus one charge. So charge 1 decreases. Charge 1, negative charge, goes outside. And the mass, what will happen? Beta decay. Which answer is correct? I think there is a mistake in the answer. By beta decay, this is what will be here. When one negative charge decreases, negative charge, this will have a negative charge going out. Means neutron, this is beta decay. How it emits an electron? Product emits an electron. This. How the product emits electron? Electron going means neutron changing to proton. This is the neutron changing to proton. So one neutron of this is converted to proton and electron emitted. So this means the electron emitted mass remains nearly same, because by emission of electron mass is much smaller of electron as will compare nucleon. So what will happen? Mass remains same. Charge will increase because one proton increases. So this answer is that this becomes 93. Whatever here, the Pu, they say Pu, 93 Pu, mass remains same, 238. So I think this, no answer is correct. So what should be there? 93. Here 92, 90, 93, 94. So here is charge 93. So this mass should not be 237 because mass remains same. This should be 238. If this is 238, then this will be correct. Otherwise, this 239. How this 238 changes to mass of this changing will not changing, because whatever mass this here, mass must be same. Only charge must increase this. So this answer, you have to write this 238, and in this, whatever earlier, this was wrong. So I think that when charge changes by 1 unit, neutron changes to proton. So this is not 94, 92, 92, 90, 93, 94. So because charge increased from 92 to 1 unit, so this must be correct. And the mass remains same. But mass here is 239. What? Yeah, 239. 238 decaying. This is 239. It cannot be 239. Mass will not increase. This will not. So this is wrong, because mass will not increase when electron emission. This mass will not change. So only this mass remains same, charge will change by 1. This can be correct. If this is 238, in the question it was 237, so that was wrong. So it should be 238. 90, we get here 93, Pu 238. So this is correct answer. We should be careful, because when electron emission takes place means beta decay happening. Otherwise electron will not emit itself. That is not possible. Electron will not come out from atom because it is bound. Electron comes out means by some process. Which process? They should stay. Just by bombarding some particle, electron emits out. That is a different thing. That is the negative charge decreases 1 unit. And beta decay take place, then positive charge increases by 1 unit because neutron changes to proton. So this is beta decay. In beta decay, charge increases by 1 unit and mass remains same. No mass change. Okay, let us have some other example. We do some other question. 3. The activity of a radioactive element. Activity of a radioactive element decreases to 1/3 of original activity. Decreases 1/3 of original activity. Good. The activity of that is A naught. Now, in a period of 9 years, after a further lapse of 9 years, after a further lapse 9 years, after a further lapse of 9 years, the activity will be the activity of a radioactive element decreases to 1/3 of the original activity. In 9 years, it becomes 1/3. Its half-life is not given. The answers are, from answers you should guess the correct answer. The answer is A naught, B is 2/3 A naught, C is A naught by 9, and D is A naught by 6. What will be the correct answer? How to get? In 9 years, it becomes 1/3. So either you get by the equation A is equal to A naught e to the power minus lambda t. It is possible to get. Or you guess that in 9 years it becomes 1/3. So after the 9 years more, it will, in 9 years it become 1/3 of A naught 3. So you see now A naught 3. So further 9 years it will become 1/3 further. So 1/3 of A naught by 3, like that. In 9 years, the activity is 1/3 of A naught. So in another 9 years, it will be 1/3 of this, because here it becomes A naught, starting A naught. In 9 years it becomes 1/3 of A naught. Further 9 years it will be 1/3 of this. So obvious, there is no need of any calculation, etc. Obvious. So it will be 1 by 9 A naught. And here A naught, this is wrong. 2 by 3, how 2 by 3 possible not. A naught by 6 also not correct. A naught by 9 means this answer. So C part is correct. Because we started from A naught. In 9 years it becomes 1/3 of this. So further same time. If you change the time 4 years, 5 years, 6 years, you cannot guess. But time remaining same. So further 9 years, so it will be 1/3 of this. Now you can say further 9 years, it will be 1/3 of this. Further. 1/3 of 1 by 9 A naught. So in another 9 years, it becomes A naught by 27. And because I am not changing time. If we change time, maybe 4 years or 5 years, the answer you have to calculate by this formula. And without the formula, from the common sense, you can get that we started from A naught. In 9 years, it became 1/3 of original A naught. Now this is original. After 9 years of this, it will be 1/3 of original. So 1/3 of this original. So this becomes 1 by 9 A naught. So C is the correct answer. Now we will solve some other question. Say, question 4 is the half-life of the half-life of a radioactive decay is x times mean life, is x time of its mean life. Good. The value of x is find out the value of x. The answers are 0.3, 01, 0.693, B is 0.693, C is 0.66020, and D is 1 by 0.693. So this is the question. The question is that the relation between half-life and mean life, half-life and mean life, how they are related. So the question gives here that the half-life of a radioactive substance is x times of its mean life. The half-life of a radioactive decay is x times of its mean life. So what the relation in mean life and half-life? You can get. From that you will get answer. By definition, half-life T half is equal to 0 log, natural log of 2. That is 6.693 divided by lambda. And mean life tau is how defined? It is 1 by lambda, inverse of decay constant. So obviously, the value of x, the half-life of a radioactive decay is x times of mean life. This. So tau is half-life is x times of mean life. So t half is x times of tau. That means it is x times of x by lambda. So what is the x? Well, compare here this. T half is this. So what is x? X is equal to 0.693 or natural log of 2. So 0.693 means B part. This is the correct answer. B is the correct answer. Very obvious. If you remember the relation, because we know that from the formula T half is ln 2 over lambda. And ln 2 means 0.693. So this is the correct answer of this is x is equal to 0.693. I am solving some problem as an example and helping you so that you can do some more problem yourself because I can't solve many problems here. I am giving some examples just how to solve. Okay. Another problem is but number 5, neutron decay in the free space neutron decay in the free space is given by, well, how neutron decays in free space? Neutron decays to the proton that you know. 0 charge, 1 mass, neutron decays to 1 H1 plus what else? Minus 1 electron of 0 mass plus something else. What is this something else? The answer is A, photon, means this X. What is this X? X is what? Photon. B, graviton. C, neutrino. And D, antineutrino. So what the correct answer is? Neutron decays by emission of which particles? Out of these 4. When we talked about beta decay, I explained to you that how the beta decay takes place, what particle is coming out. So that is, and I gave at that time you the neutrino idea. Neutrino Fermi theory of beta decay is not experiment +2 course, but beta decay is given, and that was the assumption that neutrino is coming out, neutrino and antineutrino. 2 particles are there. 2 types of beta decay, negative beta decay and positive beta decay. So which beta decay is positive, where beta plus means positive is coming out, and 1 beta decay is negative beta, that is electron coming out. So that here which particle? You see, photon cannot be there because we have to explain how from where photon coming out. Graviton is no graviton is gravitational particle. Neutrino, it can be either neutrino or anti-neutrino. But I have explained you that when there is a particle here, here should be anti-particle. Why? From the particle physics, there is law of conservation of lepton number. Lepton number on both sides must be conserved. This is a nucleon, so lepton number is 0 here. This is a nucleon, so lepton number here is 0 because lepton number is +1, for anti-lepton it is -1. So this is a electron is lepton, so electron number is +1. Conservation of lepton number. Here lepton number is +1 say. So it should be a particle which have lepton number -1. So that lepton number is 0. Because lepton number here is 0 and here is 0. So this should be a particle that is antiparticle. So +1 and -1. So antiparticle means anti-neutron. So answer should be anti-neutron. And beta positive decay. Beta positive is the antiparticle. So this has got lepton number -1. So it should be a particle. Particle means neutrino. So in the neutrino theory, neutrino hypothesis, we have explained that neutrino is emitted with beta positive decay because there is a antiparticle emission. Here particle emission, so the other particle must be anti-neutrino. So answer is anti-neutrino. This is the correct answer and not neutrino. Because conservation of lepton number is required for this decay. And lepton number for the nucleon is 0. Lepton number for particle, electron and neutrino. +1, anti-neutrino -1. Neutrino +1, anti-neutrino -1. Okay? So this is the correct answer. That beta, remember now, that beta decay we have emission of anti-neutrino for the conservation of energy, for the conservation of spin angular momentum, etc. That beta decay I explained once. You can see my other lectures where I explain beta decay. Okay? Now next is a nucleus ZAX. A nucleus emits an alpha particle. A nucleus emits an alpha particle. Good. And the resultant nucleus emits a beta particle. Emits a beta particle. So emitter alpha particle and beta particle, the respective atomic and mass numbers of the final nucleus will be the mass and atomic number. Of a residual nucleus. That is final nucleus will be. So what will be the final nucleus? Answers are here. Z minus 3, A minus 4. answer of B is Z minus 1, A minus 4. Answer C is Z minus 2 and A minus 4. Answer D is Z and A minus 2. Now you have to tell me what the alpha decay and what the beta decay. This is the combination of alpha particle coming out, so alpha decay and then beta decay. Alpha decay and beta decay, any nucleus. So I have explained that ZXA. When there is alpha decay, what happens? Alpha decay means 2 helium-4 is coming out. So 2 helium-4 means a particle having charge plus 2 unit. So plus 2 He4. So 4 mass particle coming out. So residual nucleus will be Y, mass will be A minus 4, and charge will be 2 less, means Z minus 2 when alpha particle comes out. Right? So that the mass conserve, charge conserve. Now this nucleus is having beta decay. So Z minus 2 Z minus 2 and Y A minus 4 decaying by beta emission. Beta emission means minus 1 charge and 0 mass. So this will have Z minus 2 is charge. 1 charge, minus charge going out. Minus charge going out means positive charge increasing, because beta decay means neutron converted into proton. So positive charge increase means positive charge becomes Z minus 1. And this is Z. Charge increase and the mass remains same because mass is not going. So output final residual nucleus is Z minus 1 and A minus 4. And here you can see that Z minus 1 and A minus 4 is the answer. So this B part is the correct answer, others are wrong. Means the residual nucleus or final nucleus will have charge Z minus 1 and mass A minus 4. Okay, so this is the B part is the correct answer. Now we see some other question. Another question is certain radioactive substance. This is now 7. Certain radioactive substance reduces to 25%. Reduces to 25% of its value, of its initial value in 16 days. Its half-life is so what the half-life is? 25% is it means 1/4 in 16 days. it becomes 1 by 4, means 75% decay. 25% remaining means it remains, reduces to, substance reduces to. It means from initial, it decays 75% decay, 75% decay. The question is 75%. So answers are, choices are here. 32 days, 8 days, 64 days, and 28 days. Which is correct answer? You see, this question is also from common sense. They are saying that, you see, what is the half-life? Half-life means that system decays by 50%. It remains half of its initial. Here the system is in 16 days going to 25% of its original, means 75% decay. It becomes 1 by 4. So 25% remaining. So it means 1 by 4. Residual activity is 1 by 4 of initial, means A naught. Common sense is that in half-life period, activity is 1 by 2 of A naught. It is 1 by 4 of A naught. So it is, residual is 1 by 2 of, it means from this also half becomes it, half of this, here half of this. So half, this is half-life. They are asking half-life. In one half-life, it becomes 1 by 2 of initial. In another half-life, it becomes 1 by 2 of this, means 1 by 4, 25% remaining. So, this is, in this same period, this becomes here, and half of this means this. So, what will be the half-life? Because 16 days is initial half, the activity is 1/4 in 16 days. So what you guess? In this, it cannot be 32, it is very large. This is also very large because half becomes in 16 days and further half in 16 days. So what the half-life is? 64 days also very large. Only remaining is 8 days. 8 days is the half. Because in 8 days it becomes half. In further 8 days means total 16 days. It becomes 1 by 4. The simple common sense question. Or you can get from the formula also that A is equal to A naught to power 2 to power n. Where half-life, n is the multiple of half-life. Here it is 2, because from here to here it becomes half of this. So n is 2. Then you can get half-life, or you can get from the A is equal to A naught, that will be long, e to the power minus lambda t. From here, you get here also A is, say, here half A is A naught by 4 and that is remaining, and that is A naught e to power minus lambda t. You have to find out t is 16 days, and this is 0.693 half-life, and this is a time 16. So just mathematical thing. You can solve this. A naught gets cancelled. Then you see e to power 0.693 into 16 t half is equal to 4. So just with the help of exponential table or your calculator, you can get this thing is natural log of this means 0.693 0.693 into 16 divided by t half is equal to ln of 4. Ln of 4 means ln of 2 square, and 2 ln we know. This is twice of ln of 2. This means twice of 0.693. So this thing is, now you can find out from this t half. Well, t half is equal to 0.693 into 16 divided by this thing 0.693 into 2. So this cancels this 2 is so t half is 8. So this answer is correct. So either you do within no time from your common sense, or you apply mathematical formula, you get like this. It takes some time. But if you do fast, I think it will take not more than 1 minute. You can get the answer mathematically also. But I wrote here by common sense, because common sense is that it cannot be half-life, and because 3/4 decay by in 16 days. So, but the half-life? Half-life will be less than this. So 28 is not correct, 64 is not correct, 32 is not correct. Half-life is less than 16 days. So this is the 8 days. Common sense. Otherwise, mathematically you can do like this, and that is the correct method of doing any problem, but it takes some time. Now we do another problem. Say, a certain radioactive element has half-life of 4 days. Half-life is 4 days. The fraction of material the fraction of material that decays in 2 days is, in 4 days it becomes half. In 2 days, how much decay? So what the remaining answer is 1 by 2. B is 1 by root 2. C is under root 2. D is under root 2 minus 1 divided by under root 2. So which is the correct answer? You have to solve. 4 days half-life is certain element half-life 4 days. So 4 days it becomes half. The fraction of material that decays in 2 days, how much it will decay? Decays fast. When the activity is large, decays fast. It is exponential. When activity remains small, it is small decay. So what is the correct answer? How much? 2 days. Half-life is given 4 days. You see, we have a question. We have a formula that A is equal to A naught by 2 to power n, when time is some integer multiple of half-life. When n is a number, so that when time is multiple of n multiple of half-life. Means when time in the formula A is equal to A naught e to power minus lambda t, this time t is say n multi times of half-life. If this is the problem, that time, the fraction of material decays in 2 days. So if this time is t is 2 days. T is equal to after 2 days how much activity. So when time is multiple, some multiple of half-life. So what the multiple here? Half-life is 4. So what this time? How you will get time? What the multiple? It is under root of 4, means 4 to power 1 by 2. That is t is equal to n times t half. T is equal to 4, and that is half-life is 4. So that 4, how this 4 will be there? How we will get t is equal to 4? So what the n? T half is 1 by 4. T half is 4 days, 4. And time is 2. Time is 2 days. So how we will get multiple? So n is 1 by 2. Well, n is 1 by 2. So A is equal to A naught 2 to power 1 by 2. This is the formula. When n is, time is multiple of half-life. What multiple of? Multiple is n, 1 by 2. So this is the activity after 2 days. You can get the fraction of the fraction of material that decays in 2 days is how much? Like this. So what the answer is? The certain relative half-life is 4 days. The fraction of material that decays. So this is the remaining. Initial A naught. This is remaining. So decays. How much decay? From this you subtract this because this remaining, this is available. So how much has lost? Decay is A naught minus A naught by under root 2 to the power half. So that is how much? Under root 2 minus 1 by under root 2 and this A naught. So what the fraction? Fraction of remaining. Fraction of remaining material is A naught, A over A naught. How much is A over A naught? Fraction, this is A, remaining A naught initial, A over A naught. And this is, remember, A. So A over A naught means under root 2 minus 1 under root 2. So this D part is correct answer. Under root 2 minus 1. So I have solved this question using this knowledge, that formula, that A is A naught to the power n. When n is the fraction, half-life is either 2 times, 4 times, or some integer multiple, some number that you know. So this becomes the remaining material fraction of that, A over A naught. This. So answer after 4 is D part. Now another question is, in the disintegration series, what series? What's the series? In the disintegration series, 92 uranium 238 decays by alpha emission to, say, X, and then it decays by beta emission to Y. The value of Z and A respectively will be the value of Z and A will be. Final thing will be what? Well, we can solve here. Or I write the fourth answer. A is 92, 30, 236. B is 88, 230. C is 90, 234. And D is 91, 234. So see that alpha decay means mass decrease by 4 units, because mass of this is 4 units. So this 238 becomes here. This is mass decreases by X is here. This becomes 234. And this 92 changes by alpha takes 2. So this becomes 2 less 90. 90 to 34. And then this by, this beta decay. Beta decay mass remains same. And charge increases by 1 unit. This becomes 91. So answer is here, 91 to 34. Whatever this given here, this is the correct answer. This is not, this is not, this is not. Because our charge is 91, mass is 234. So this is the correct answer. Well, I will do now one more question. I want to do, say, about 10 questions today. I will do some 10 more tomorrow. So question number 10 is in the case of thorium, A32 Z equal to 90. In the case of thorium, we obtain an isotope of lead. An isotope of Pb. What isotope? A is equal to 208 and Z equal to 82. This we got after some radioactivity. The number of alpha beta particles emitted are the number of alpha and beta particles emitted are the answers are given here. A is 6 and 3, B is 6 and 4, C is 5, 5, D is 4 and 6. How we get the correct answer here, that how much alpha particles and how much beta particles, how many emitted. A is 232, A is 208 here, Z was 90, Z is here, 282. And remember, when beta integrated takes place, there is no mass change. Only mass change is in alpha decay. Mass 232, 208. So how many alpha? One alpha goes out, 4 mass decreases. So 4, 4, 4. What is the difference? 32, 24. 24 difference mass. So 24 means 4 into 6. So alpha is equal to 6. It means 6 alphas are emitted. So this answer is not correct. This answer is not correct. These two may be correct. We have to check because alpha are 6 here. So alpha is 6. Now how many betas? When 6 alphas are emitted, 1 alpha emitted, 2 charge decreases. 6 alpha emitted, 2 into 6, 12 charge decreases. So 232 Z90. So 12 charge decrease means 90 minus 12, 78. 78 charge. Now charge is actually 82. So 78 becomes 82. How? 4 charge. 4 charge means, so from 78, one particle beta emitter, one charge increases. 4 charge from 78, 82. How? By emission of 4 beta particles. So this means 4 beta particles. So beta particles are 4. So this answer is correct and not this. I again explain. When 1 alpha four mass decrease. Here 232 to 8. In the question, mass decrease is 232 into 8. 232 minus 208, that is 24. So alpha emitted 24 divided by 4 means 6. So 6 alpha emitted. Now how many beta? Charge change, charge decrease by 6 alpha emission is 12. Because 1 alpha emission, 2 plus charge decreases. Alpha takes 2 charge. So 12 charge decreases. Here, charge decrease. Charge after alpha emission. Because 12 decrease. From 90 minus 12 is 78. But final charge is 82. So 82 minus 78 equal to 4. How 4 charge increase? 4 charge increase by 4 beta emission. Because 1 beta emission, 1 positive charge increases. So that means the answer is 6 and 4. This is the correct answer and not any other answer. So friends, today I stop here. Tomorrow when we will meet, I will do some more problems, maybe 10 more problems, because problems are asked in the examination, more problems. So I will do, one day I will explain some physics phenomena, some physics also, and then do some problem. Okay? So thank you very much.